Swayam Prabha. Digital India. Educated India.
Hi everyone, welcome to the lecture number 11, the third lecture on labor demand. During our earlier discussion, we analyzed the hiring decision of firms to hire labor in short run as well as in long run. Further, we derived the short run and long run labor demand curves of the firm as well as for the industry. Now we turn to the discussion of estimates of labor demand elasticity. So, as usual, we use the concept of elasticity to measure the responsiveness of the change in the employment to change in wage. So, we will discuss the labor demand elasticity in the short run as well as in the long run. As we know, the production function, they differ in the short run as well as in the long run. In the short run, where you have some constants, some inputs are fixed which you cannot change, whereas in the long run the firm do not have any constant. So, the elasticity of labor demand will be different for the firm both in the short run as well as in the long run. So, the short run elasticity of labor demand is nothing but it is the percentage change in the employment by percentage change in the wage, and this percentage change in the employment mostly related to the short run employment. So, you can see in this equation is that delta ESR by ES, which is the change in the employment in the short run, divided by delta W by W, which is the change in the wages. So, how we interpret this elasticity value? The short run elasticity of labor demand, as I said, is defined as the percentage change in the short run employment resulting from 1% change in the wage. So, the value of the elasticity we explain is that the change in the employment due to change in 1% change in the wage. So, the short run demand curve for the labor is downward sloping, as we have already derived it. Therefore, the short run elasticity of labor demand will be negative. The sign of this elasticity value will be negative. If you remember our example in our previous lecture, we have seen that the industry hires 30 workers when the wage is $20 and hires 56 workers if the wage falls to $10. So, if we want to estimate the short run elasticity, we can estimate it simply by the percentage change in the employment by percentage change in the wage. So, employment has increased from 30 to 56. So, percentage change in the employment is nothing but 56 minus 30 divided by 30 whole divided by the percentage change in the wage, which is nothing but wage has increased from 10 to 20. So, 10 minus 20 divided by 20, the value comes out to be minus 1.733. So, this is how we can estimate the elasticity value. When it comes to long run, the same formula is used to estimate the long run elasticity of labor demand. It is the percentage change in the employment by percentage change in the wage, and it is the same way we can interpret the results that the percentage change in the long run employment resulting from 1% change in the wage. The long run demand curve is also again downward sloping. Therefore, the long run elasticity value will have a negative sign. When we discuss about this long run elasticity of labor demand and short run elasticity of labor demand, an important principle in the economics states that the consumers and the farms can respond more easily to the change in the economic environment when they face fewer constraints. Like as I said, in the long run, there is no constraint to change the level of output. All the factor inputs are variable. So put it differently, unnecessary constraints prevents us from fully taking advantage of the opportunity presented by the changing prices. So in terms of our analysis, this principle implies that the long run demand curve for labor is more elastic, more responsive towards the change in the wage than the short run demand for labor. So the short run demand for labor is less elastic and the long run labor demand is more elastic, because in the long run the farms can adjust both capital and labor and can fully take advantage of the changes in the price of the labor, whereas in the short run the farm is stuck with fixed capital stock and cannot adjust its size easily. So if you plot the labor demand curves in the short run and in the long run, you will find that the long run demand curves are more flatter, as you can see in this graph. The long run demand curve is much flatter, which means more elastic in nature, whereas the short run demand curve, they are much stiffer, they are less elastic. You can see any changes happens to the wage rate, the responsiveness, the change in the employment, a small change in the wage can bring a large amount of change in the employment in long run, whereas in short run it is less responsive. The employment change is less responsive. A large amount of change in wage brings a small amount of change in the employment. There are many empirical studies, those who attempted to estimate the elasticity of labor demand. Given our earlier discussion of the problems encountered in the estimating labor supply elasticity while discussing the labor supply, it should not be surprising that there is a huge range of variation in the estimation of this labor demand elasticity. Although most of these estimates indicate that labor demand curve is downward sloping, therefore there will be a negative sign. However, the range of the estimates, they vary at a larger degree. Despite of this dispersion in the estimates of this short run labor demand elasticity, most of the literature, they come to the consensus that the elasticity value lies between 0.4 to 0.5, which means a 10% increase in the wage reduces the employment perhaps by 4 to 5 percentage point in the short run. Further, the evidences also suggest that the estimates of the long run demand elasticity, it clusters around 1, closer to 1, and sometimes it is 1. So the long run labor demand curve indeed more elastic than the short run labor demand curve. So in the long run, if we see, in the long run, a 10% change in the wages leads to a 10% change in the employment. Further, while decomposing this effect, it has been observed that in the long run, about 1/3 of the long run elasticity can be attributed to the substitution effect, and about 2/3 of this can be attributed to the scale effect. While discussing about this elasticity of labor demand, it is important to discuss the concept of elasticity of substitution. When we talk about the elasticity of substitution, it depends on the curvature of this isoquants, the production functions. When the marginal rate of technical substitution is constant, which means the isoquant is having a straight line here in this graph you can see the isoquant is having a straight line. Now, to produce Q0 amount of output, the farm can employ any combination of these factor inputs, both labor and capital. If you look at this the slope of this isoquant, the slope of the isoquant here is minus 0.5 and which is fixed over this isoquant. So, the slope is constant, which means that these two inputs in the production can be substituted at a constant rate. So, 2 units of labor can be substituted by 1 unit of capital, and that substitution is fixed over the process of production to produce Q0 level of output. So, these two inputs are called perfectly substitute to each other. When the isoquant is having right angle shape, as it has been shown in this graph, you can see to produce Q0 level of output, the farm is employing 5 units of capital and 20 units of labor. So, when the shape of the isoquant is right angled, the two inputs which are used in the process of production, they are called perfectly complement. They complement each other. So, any change keeping the level of output constant to produce Q0 level of output, and if the farm is fixing the level of employment at 20, adding more capital to the production is not going to increase the level of production. Similarly, if the farm wants to fix the level of capital and trying to add more labor, it is also not going to increase the level of output. So, a perfect combination of this capital and labor is 5 and 20 to produce Q0 level of output. In this case, these two inputs are perfectly complement to each other. So, the right angle isoquant implies that this using 20 workers and 5 machines yields Q0 units of output. If we hold the capital constant at 5 units, adding more workers has no impact on the level of output. Similarly, if we hold labor constant at 20 workers, adding more machines has no impact on the level of output. So, a farm that does not wish to throw away money has only one recipe to produce Q0 level of output, that is 20 workers and 5 machines. So, when the isoquant between any two inputs is right angle, these two inputs are called perfectly complement. Here, when the substitution effect is very large, then the labor and capital are perfectly substitute and the isoquant will have a linear line, which means the farm maximizes the cost of producing Q0 units of output by hiring either 100 machines or 200 workers, depending on which of these two alternatives is cheaper. If the prices of the inputs change sufficiently, the farm will jump from one extreme to the other. Either he will employ more capital or he will employ more workers. In contrast, when there is no substitution effect, the two inputs are perfect complement, because there is only one recipe for producing Q0 units of output and a change in the ways does not alter the input mix at all. So, the farm must use 20 workers and 5 machines to produce Q0 unit of output regardless of the price of the labor and capital. Now, we have discussed one extreme where these two inputs are perfectly substitute, and the another extreme that these two inputs are perfectly complement. So, in between these two extremes, there are a large number of substitutions possibilities, which depends on the curvature of the isoquant. The more curved the isoquant, the smaller the size of the substitution effect. Now, to measure the curvature of the isoquant, we typically use a number called elasticity of substitution, which means how these two inputs are being substituted in the process of production. So, elasticity of substitution between capital and labor holding the output constant can be defined as the percentage change in the capital labor ratio resulting from 1% change in the relative price of labor. So, this can be measured simply by the percentage change in the capital output ratio divided by the percentage change in the price for the capital and the price of labor. As the relative price of the labor increases, the substitution effect tells us that the capital labor ratio increases, which means the firms they get rid of the labor and replace it with capital. Therefore, the elasticity of substitution is defined as a positive number. The elasticity of your substitution turns out to be 0 if the isoquant is right angled, which means there is no substitution, and the elasticity of substitution turns out to be infinite if the isoquant is linear. Therefore, the size of the substitution effect, it directly depends on the magnitude of the elasticity of substitution. Now, while discussing about this elasticity of labor demand and the elasticity of substitution, it is important to discuss about the Marshall's rule of derived demand. Here we are not discussing or deriving the mathematical equations of this Marshall's rule of derived demand. Simply we are discussing about these the rules and its implication on the labor market and the labor demand. Marshall's rule of derived demand describes that the situation that are likely to generate elastic labor demand curve in a particular industry. So, the first rule of Marshall's rule of derived demand is that labor demand is more elastic the greater the elasticity of substitution. So, higher the elasticity of substitution, higher will be the labor demand will be more elastic in nature. This rule follows from the fact that the size of the substitution effect depends on the curvature of the isoquant, the slope of the isoquant. So, greater the elasticity of substitution, the more the isoquant looks like a straight line and more similar labor and capital are in the process of production. So, this allows the firm easily to substitute labor and capital as the wage increases. So, in that case it will be more elastic in nature, the labor demand will be more elastic in nature, as it has been seen in the long run labor demand elasticity curve. Coming to the rule number 2, the labor demand is more elastic the greater the elasticity of demand for output, which means if the demand for output in the product market is more elastic, then the elasticity is high in the product market, then the labor demand is more elastic. Let us discuss it, how it happens. So, when wage rises, the marginal cost of the production increases. Therefore, an increase in the wage raises the industry's price in the product market. As the price in the product market increases, it reduces the consumer's demand for the product in the product market. Now, because the output is less sold in the product market because of the increase in the price, the firm will cut down its employment, firm will reduce its production. So, the greater the reduction in the consumer demand, which means the more elastic the product in the product market, the larger the cut in the employment and more elastic the industry's labor demand curve. Now, moving to the third rule of Marshall's derived demand is that labor demand is more elastic the greater the labor's share in the total cost. So, as per this rule, if the labor share is greater in the total cost, the labor demand will be more elastic. Suppose the labor is a relatively important input in the process of production, in the sense that the labor share of total cost is large. This kind of situation might occur, for example, when the production is very labor intensive, as with a farm using highly trained craftspeople to produce expensive handmade ornaments. So, if it is an ornament producing farm and mostly takes into consideration the craftspeople and to prepare these ornaments by the labor by their hand. So, it is mostly a labor intensive industry. So, in this case, even a small increase in the wage rate would substantially increase the marginal cost of the production. As the marginal cost of production increases, the output price has to go up, and this induces the consumer to cut back on their purchases on the ornaments. So, the demand for these goods and services will go down. Now, what will happen for the farm? The farm in turn would cut back the employment substantially. However, if the labor is an unimportant factor of production, in that case labor makes up only a small share of the total cost. Therefore, a wage increase has only a small impact on the marginal cost and on the price of the output, so as on the consumer's demand. So, in that case, the farm's employment will reduce very small magnitude. This third rule of Marshall's derived labor demand holds only when the absolute value of the elasticity of product demand exceeds the elasticity of substitution. This is the exception. So, the reason for this exception follows from the fact that we can arbitrarily make the labor very less important by redefining it superficially in a irrelevant way. Let us, for example, we can subdivide the labor input of this crafts people producing ornaments into various inputs, like different subgroups like Irish craft people, Italian craft people, Mexican craft people, and so on and so forth. Each of these labor inputs would obviously make up a very small fraction of this total cost, but it is not the correct way to say that the demand curve for Irish craft people is very less elastic than the demand curve for all other crafts people. So, here we superficially, in an irrelevant way, we try to subdivide the labor input. So, as we define the labor input into very smaller subpopulations, the elasticity of substitution among various inputs goes up. Now, how can we say there is any difference in the productivity between typical Irish and Italian craftsperson? So, the Marshall's third rule holds only when the elasticity of substitution is sufficiently small. In effect, the various labor inputs used by the farm are not essentially the same input broken into arbitrary categories, subcategories. This clarification of exception to Marshall's third rule was contributed by Stigler in his book The Theory of Price. Well, while coming to the fourth rule on Marshall's derived demand, the fourth rule talks about that the demand for labor is more elastic the greater the supply elasticity of other factors of production such as capital. So, in the process of production we use so many factors of production, so many factors of input. Elasticity of demand for labor depends on the supply elasticity of other factor inputs. We have assumed that the firms can hire as much capital as they want at the constant price R. Suppose there is a wage increase and the firms want to substitute from labor to capital. If the supply curve of capital is inelastic, so that the price of the capital increases substantially as more and more capital is hired. So, the economic incentives from moving along an isoquant are greatly reduced, which means it is not quite as profitable to get rid of the labor and employ capital instead. So, the demand for labor therefore becomes more elastic. So, the easier it is to increase the capital stock, which means more elastic supply of capital. Now, while discussing about this Marshall's rule on derived demand, we need to understand how these rules are applicable in the real world situation. We will discuss this application of this Marshall's rules through the behavior of the unions. Unions in the industry, they often come under one single umbrella. The workers come under one union. They formalize their union to negotiate and to increase the collective bargaining. So, the trade unions are immensely involved in collective bargaining and negotiating with the management. So, the unions, they act in the best interest of their membership. They negotiate with the employer on the aspects of wage, hours of work, health and safety, different social benefits, and so on so on. So, the terms agreed upon are usually legally binding. So, now let us try to understand how this trade unions behavior impacts the elasticity of labor demand. The behavior of labor unions shows that how Marshall's rules can help us to understand various aspects of the labor market. Let us for example consider a competitive firm that is initially non-union, there is no union in that firm. So, the firm hires 1000 workers at a going wage rate. Now, a union wants to organize the firm's workers and promise the workers that the collective bargaining will increase their wages substantially. Because the firm's labor demand is downward sloping, the firm may respond to the higher wages by moving up on its demand curve and cutting back the employment. Now, the union, they are organizing the drive that they should all come under one umbrella and the union has to be there, worker union has to be there. So, the union's organizing drive has a greater chance of being successful when the demand for labor is inelastic in nature. After all, an inelastic demand curve ensures that employment is relatively stable even if the workers get a huge wage increase, which means the workers would not have to worry about the employment cutback if they vote for the union and become a part of the union. So, it is in the union's best interest therefore to take whatever action are available to lower the firm's elasticity of demand. So, if the labor demand curve is inelastic, then the union will become more effective. So, in view of this fact, it is not surprising that unions are often resisting technological advances that increases the possibility of the substituting the labor and capital. Let us take for example the typesetters union. This typesetters union, they objected to the introduction of the computerized typesetting equipments in the newspaper industry for a long period of time. So, this type of behavior is an obvious attempt to reduce the value of the elasticity of substitution. The unions are resisting to computerize. By doing that, they are trying to reduce the elasticity of substitution. So, a smaller elasticity of substitution reduces the size of the substitution effect and makes the demand curve more inelastic. Similarly, unions want to limit the availability of the goods that compete with the output of the unionized firms. For example, the United Auto Workers was a strong supporter of the policies that made it difficult for the Japanese cars to crack into the US market. Now, if the United Auto Workers obtain a huge wage increase for its workers, then the price of this American made car would rise substantially. Now, this price increase would drive many potential buyers towards the foreign imports, towards the foreign cars rather than buying American cars. Now, if the union could prevent the entry of cars like from Toyota, Nissan, Hondas into American marketplace, then the consumers should have very few alternatives to buy a high priced American made car. So, consumers will not have any choice. So, it is the union's interest therefore to reduce the elasticity of the product demand in the product market by limiting the variety of goods that are available to the consumer. By doing so, they are forcing the consumer to buy their products only, which will reduce the elasticity. Further, Marshall's rule also imply that unions are more likely to be successful when the share of labor cost is small to the total cost of production. So, when the share of labor cost is small, then the unions can make high wage demands without raising the marginal cost of the output. So, if the marginal cost of the output is not going to increase that much, then it is not going to affect the demand for the product in the product market and the revenue of the farm and the employment decision of the farm that much. In fact, there is evidence that unions that organize small groups of workers such as electrician or carpenters tends to be very successful in getting sizable wage increases, because these specialized occupations make up a very small fraction of the total labor cost. So, the demand curve for these workers is relatively inelastic. So, this is all about the elasticity of demand in the short run and long run, how the Marshall's rules affects this elasticity of demand and its application we have tried to understand through the labor union behaviors. In the next class, we will discuss about the policy applications in the labor demand, how this affirmative actions affects the production cost. Thank you.